Hi everybody, my name is Marius and today I want to do a quick video on steps to set up IPSec on HP equipment successfully, as you can see on the screen. The reason I'm doing this video is very simple. Okay, it is I've been working with a customer recently and I've worked with quite a couple of customers with IPSec over the last couple of months. And it almost seems like, you know, when you say the word IPSec, all wheels fall off and people get scared and nervous and so forth. And being an instructor a couple of years ago, one of the things that I used to do when my classroom used to do IPSec is get back to the basics, okay, with IPSec. Without any connectivity, there shall be no IPSec, okay. So what I found more times than not is that people got so involved with the IPSec and trying to troubleshoot it that they would forget about basic connectivity. Okay, so this is what I wanted to do sorry, that was a stumble. That's what I wanted to do today. Okay, is to just quickly have a very quick look. It'll just be a very quick video. It's not going to be that complicated. I just want to draw a quick picture of what I want to do today. Alright, so let's choose a color there. So effectively what I want to do is have a router that's going to be connected to a secondary router, connected to a third router, yeah, with a bit of a LAN type segment there, LAN type segment. I'll just emulate that with loopback interfaces. This will be your WAN, this will be your customer edge, and let's say this will be your hub or data center router. Yeah, so that's effectively what I would like to do today. And let's say this would be the 172.16.1.0 network and 172.16.2.0 network. Those will be a 192.168.1.0 network, let's say. Making this up 192.168.2.0 then. It's got to be, let's make this .1. I like to keep these as always .1. The WAN can be .2, it's not that important, you know, just to keep it simple. Okay, so let's put some complication in here, a little bit of complication. Let's say we're going to put a GRE tunnel in there. It just adds a bit of complexity because up to this point it's not very complicated. Let's say that's 10.1.1.0, make this .1 and .2. I think that's a pretty cool network, yeah? Okay, so effectively what we're going to do is I'm going to show you how I would approach this. I'm going to set up standard IPSec with 256-bit encryption with for phase 2, right, for IPSec. I'm going to use SHA-1 for now. Right, I'm not going to get very complicated here. It's just to show you that it works. You know, one or two things around that. Of course, from that point of view, what I want to encrypt is I only want to encrypt traffic coming from this point to this point, which means I'm going to have an access control list with a source, you know, of 192 going to 192. That's my type of traffic. Every other traffic will not be encrypted. All right, and let's say what I'm going to do is this will be interesting. I think from a troubleshooting point of view, it makes a lot of sense. I want to do the 192 networks, but I also want to do the 10 network. I want this traffic to be encrypted in the GRE tunnel. I think that could be quite cool. Okay, so that will be the access list. Yeah, everything else, so the WAN type traffic will not be encrypted. Good, and I'll do some tests around that. What can we still say about this? Right, I think what we want to do is, let's say we want to use pre-shared keys for this environment, all right? To make sure that works well, and say inside this pre-shared key we'll use a test password. That's easy enough, yeah, not complicated. Okay, I just want to reiterate, this is not really around IPSec per se, it's rather a couple of steps that's required to get to that point, right, to make sure that it works well. Okay, so let's start with the fun. I'm going to work with VSRs from HP, Virtual Services Routers. It's very easy to work with them, and I've preset 3 routers up. I typically have 3 routers set up this way already. So effectively what I can do is go there, and as you can see I've pretty much got 3 VSRs running at the moment. VSR1, VSR2, VSR3. Yep. Okay, so VSR1, if I stand to be corrected, if I remember correctly, VSR2, let me just check. Yeah, VSR1 is going to be the CPE device, yeah. That's the way I've set it up to be connected at the moment from a LAN point of view. Okay, so let's go to VSR1. Most important thing I want to do there is make sure that I first of all, you can see there's no configuration, I'm starting from completely scratch, yeah? system, let's give it a system name, so let's call this customer premises equipment. Done. Okay, that's the first thing I want to do. Then of course save it, save, false for now. Before we get any more complicated than that, I just want to make sure that we are connecting the right things to the right devices here. VSR2 is going to be the hub. Let's see, okay, there's nothing configured at the moment. Right, so system and system name is hub. That's it, okay, and say false, okay, done. And then the VSR3, so we don't get confused, you know, otherwise we get confused with these things. Okay, at the end of the day, Control D, let's see, system, and we say system name is going to be, let's call it WAN, yeah, for all intended purposes. Okay, quit, and say false. So I'm going to start with my WAN because it's the easiest device. Thinking about this, what do we want to do? Let me just jump back onto my screen again. Yep. Let's just see. Of course, I first have to break out of that. That'll work a lot. Work well. What I want to do is I first want to make sure that we have connectivity from this point to this point, so that effectively this hub can ping the customer edge. The reason I'm saying this is because my 192.168 traffic will be flowing through the GRE tunnel. I have to add a bit of complexity, otherwise this video is a waste of time. Okay, so I'm going to add a bit of complexity there. So what I'm going to start setting up is, first of all, let's first get connectivity working here. So if the 192.168 traffic is going to be prepended with a 10 network, all right, for the GRE tunnel, and then again prepended with a 172 network, it means that from a WAN point of view, I don't have to know about the 192s or the 10s to route the traffic. Because effectively what I'm going to do is, if 192 is going to have a default route that says, well, if it's 192 going to 192.168.10, I'm going to push it to my 10 network. When it goes out the 10 network, a 10 packet will be added on. I'll do this in packet format just now as well. Then from that point of view, as it basically exits the physical, because we're going to say this tunnel's source is going to be this interface there, right, which is 172.16.2.1, yeah, and that IP address will be put on there, and its destination for this tunnel will be 172.16.1.1. As long as this router knows how to get to 172.16.1.1, I don't have to know about any other IP address, because that's the only IP address WAN will look at. Okay, I'll explain that again when we get to that point. So let's first start with WAN. It needs literally 2 IP addresses for now, as I can see, and nothing else, because it doesn't have to know about any other IP address, because that'll be inside the tunnel. So let's start with WAN. This is WAN. Yep. Let's put my pen away quickly. Turn that around. Okay, so let's start having some fun here. Let's click into this. Okay, so let's say system. Let's do display interface brief. Okay, and I've got gigabit Ethernet 210. If I remember correctly, that's pointing towards the left, right? So interface gigabit 2/1/0, and IP address at the moment is 172.16.1.2/24. Make it easy. Numlock would help a lot. IP address 172.16. That's how you know somebody is not looking at the screen when he's typing, huh? 1.2/24. Right, done. And we're going to go to interface gigabit 2/2/0, which is the other one. IP address is 172.16.2.2.1.24. Right, and I quit out of this, and I say display interface brief. What do we have? We got IP there and then. Good. Jump out of it. Let's go to VSR1, which should be the CPE. Just click into it again. I know there's a way to use the putty, but I don't want too many screens open right now. Okay, maybe that's not a bad idea. Let's just use putty. That should be fun. Yep. Okay, if you bear with me 1 second, let's quickly set it up. So for putty to work, remember I've got a pipe that I need to connect to. And that will be a quick refresher as well. So let's quickly do that. Before I can connect to the pipe, I need to go to the interface. So display, line. Just want to see what we're using there. Line auxiliary 0. So line auxiliary 0. Authentication mode none. and I've got user level 15, otherwise I can't do anything. Quit. Okay, and control alt out of this. Let's do this guy as well. Hub, display line. This time it's line 1 for aux. Okay, so line aux 1, authentication mode none. That's stupid. None, and we say user level 15. Good. You're still with me at this point? All I'm doing at the moment is so I can use Putty. I can have 3 screens open, not just one. Otherwise it's going to be to and fro the whole time. So let's get out of this one, and we said VSR3, we should be the WAN. Click into it. Okay, display line. Let's see. Oh, that was clever. Display line, and that's auxiliary 1. Okay, so line auxiliary 1, authentication mode none, and I've got user actual level 15. Yeah. Okay. Quit, and let's jump out of this. Let's do this, and we go there, and we say Putty, which I will move across. Right, and say run it. Give me 1 second. Okay, and here we can pull it up there so you can see it. And now I can connect to VSR 1, 2, and 3. And the way I connect it is, of course, the pipes. Yeah, the pipe settings. So if you load it, you'll see it. All right, I'm connecting to pipe 1. Okay, so let's say open. Let's bring it across. Okay, this is spur of the moment stuff. Yeah. Let's see if we have a connection to CPE. Brilliant. Okay, CPE is up and running. Let's quickly go and grab onto Putty again. Give me 1 second. Hey, don't you just love doing this on the fly, yeah? There we're going to say run, and again we're going to say this time VSR2, load it and open. This is pipe 2, and let's go and fetch this boy. And we click into it. This should be hub. Yep, that's all working really well. Okay, so we've got hub there, and we've got CPE, and give me 1 second, just the last one quickly. Let's grab Putty again, run it. If you give me a couple of seconds, I'm just doing this exactly the same thing, and let's bring this in. Okay, now I've got WAN. Okay, remember that you have to do the auxiliary port, otherwise you wouldn't get a login. The login would fail. Okay, let's get that one open and this one open. Good. So I've got CPE, I've got WAN, and I've got the hub. How awesome is that? Okay, so let's get going. So I'm on the customer edge at the moment. So display interface brief. I think I was messing around with this a bit. I think it was 120, if I remember correctly. Interface gigabit 1/2/0. I've been messing around a little bit. Oh, that way up. Okay, there we're in there, and we say IP address. This is a 172 network, yeah? 172.16.1.124. Okay, and let's see, ping 172.16.1.1. Can I ping myself? Oh, it's always important. And I can ping 2 as well, which means at the moment I've got basic connectivity here. Okay, I'll show you something just now. I know it's not going to work all the way through, but bear with me. Okay, so display interface brief. What do we have? We've got gigabit 210. Okay, so system interface gigabit 210. Okay, and we say IP address is 172.16.2.124, and we say ping 172.16.2.2. The other side, I can ping this guy as well. Okay, so at least at this point I can ping basic connectivity. I can ping from there to there and from there to there. Okay, so what I can also do is I can ping. I should be able to, no, I'm not going to be able to ping from customer edge to host. Okay, because simply if you do a display IP root for the 172.16.2.0, I won't have a root for it. I haven't created a root yet. So let's do that. IP root static. To get to 172.16.2.0, go via 172.16.1.2. 2. Okay. Ah, sorry about the mask. I always do that. This is not OSPF and it's not a access list. Oh man, I love it. This is just real, you know. Display IP root for 172.16.2.0. Okay, display IP routing table. Display IP routing table. Yeah. 172.16.2.0. Okay, there we have it. A little still early in the morning. Okay, 172.16.1.2. So I should be able to ping 172.16.2.2. Okay, but I won't be able to ping 1. Anybody know why? Yeah, simple. Okay, we all know why. Okay, Control C. That's because we don't have a return route. So what I can do is I can ping to this guy, that interface there, because I've got a route for it. I can also ping to the other side, to him. And since this router WAN knows how to get back to this network, he will basically return the traffic. But as soon as I ping any further than that, he doesn't know how to get back. So let's go back to him. And say IP route static to get to 172.16.1.0. This time we'll get it right. Go via 172.16.2.2. Yeah? Okay. And if I do a ping now, 172.16.1.1 to the other side, I can now ping 1.1. So, which means I can ping literally across both sides. This time I should be able to ping through. Yep, okay, easy enough. Not difficult. Okay, so this is one of the basic steps that you have to do. I'm seeing a lot of this. I see a lot of guys going into complex configurations, and what they do is they'll take a configuration that they believe works, and they'll start to adjust that configuration on IP addressing. Now once they have the IP addressing set up with all the stuff inside it, you know, the IPSec and everything else, they just copy the whole configuration in and hope in hell and pray like hell that it works. Okay, this is copy and pray that it actually works. If it doesn't work, they, what do we do? Okay, even if you're going to copy and paste configs into a routing infrastructure, please make sure that the basics work before you get to the complex stuff. Yeah, I know it's a little hard work here because you have to first unapply, not copy, the line of code on the interface that binds the IPSec to the interface, otherwise it won't work. But get connectivity working first, man. You know, I see this a lot. I've seen it actually in the last week with a customer where they were struggling to get IPSec working. And since it's the most complicated part of the configuration, that's the first thing they'll blame as well when things don't work. Okay, so what was next? Okay, so now we have connectivity from customer edge to host, a hub, sorry, inside the actual WAN infrastructure, public infrastructure. So let's create a tunnel interface. Interface tunnel 0. Okay, of course, the mode GRE. That's what I want. I'm going to give an IP address of 10.1.1 and 24. Okay, so we've got that. And I'm going to say my source at the moment is 172.16.1.1, alright, and my destination is 172.16.2.1. Am I correct there? Yep, you happy with that? Okay, let's do that. And good. And we say display interface brief. And what do we have now? We have a tunnel. Very important, very, very, very important. This is not a GRE lecture, but this shows up because it's local significant only. Since there is a way for it to get to the 2.1 network, right? If you did a display IP routing table for 172.16.2.1, since it's in there, it's got a capability, it brings the tunnel up. Very important. It doesn't mean that there's connectivity. I can prove it. It gets worse than this. 10.1.1.1, yeah, I can ping myself, but in theory, the other side's not even existent at the moment. Remember, it's a logical port, it's not a physical port. There's no physical checking on the GRE tunnel. Okay, keep this in mind, please. Okay, so I've seen this where guys can ping their own interfaces and they can't ping the other side and they have no idea what's going on. Okay, anyway, so interface tunnel 0. And I keep on doing that because I do so many of the others. IP address 10.1.1.2.24, right? And I'm going to say my source this time is 172.16.2.1, and my destination is 172.16.1.1. Yep. Quick, let's see this. Display interface brief. Let's just make sure everything's working there, and I can ping 10.1.1.2 and I can ping 10.1.1.1, and which means my tunnel's up and running. Not too complicated at all. Okay, right now. So the next step I want to do is I want to create an interface loopback 100, let's say, and we're going to give it an IP address of 192. 192.168. What did we say? 2.1, yeah? 24. Okay, and display this. Okay, good. And we're going to go to this side and we're going to say interface loop 100 IP address 192.168 dot, what do we say, 1.1. Okay, and display this. I've got that all set up. Good. I do a lot of checking. Yeah, I just like to double check myself. Display interface brief. It should all be running at the moment, but the reality is you are not going to be able to ping the 2 at the moment because there is no IP route for it. Display IP routing table for 192.168.2.0, and there's nothing there. Okay, so how do we want the traffic to flow? We want the traffic to flow from this network here through the GRE tunnel, because we don't want the WAN to see the traffic at the moment. We want to hide it away from the WAN, and flow through the network and come out the other side. So my next hop, 192.168.10 to go to 2.0, my next hop from this network will be this tunnel interface destination. Happy about that. And vice versa. I want to go from 192.168.2.0 to 1.0 through this interface, 10.1.1.1. Okay, so let's set it up. IP route static, right? To get to 192.168.2.0, 245, I'll get it right eventually. Right, go via 10.101.2. Okay. So if I do a display IP route this time, to get to 192.168.2.0, okay, and 20 won't work, 2.0, I now have a next hop that says 10.1.1.2. That's pretty cool, okay, and that's what we want. And IP route static, you might be asking yourself, what does this got to do with IPSec? Everything, okay, because if this doesn't work, IPSec won't work. Okay, to get to 192.168.1.0, go 245.245.245.0, go via, what do we say, 10.1.1.1, yep, and let's say ping 192.168.1.1, whoopsie uncle. Okay, that works. And let's say ping 192.168.2.1, and that works. And we say ping minus a 192.168.1.1. Y minus a is coming from a source of 1.1, making sure everything works, to 192.168.2.1. That'll be the end result. That will be my encrypted traffic and 10 traffic. Okay, so I'm all ready and set to go. If you don't have connectivity, don't proceed until you have connectivity. Whatever you need to do, routing protocols, I don't care, make it work. Okay. So before we go any further, you need to know that this is working. So what do we want to do next? Okay, so the first thing in, of course, IPSec, the most important thing. After connectivity issues, the most common problem that you'll find is that people are not matching up the access lists, or they get it all wrong, and they go IP permit, IP any, and good stuff like that, and suddenly OSPF is being encrypted one side. Nightmare. Know what you want. I want traffic 192 going to 192 to be encrypted, nothing else. Okay, and I want traffic 10 to be encrypted, going from 10 to 10. Okay, so any traffic inside this tunnel needs to be, of course, not any traffic, but I want a 10 to 10 traffic. So if I ping from a 10 interface to a 10 interface, it works. Why do we do that? Well, the reason I do that, at least from a troubleshooting point of view, it's a very easy way for me to establish tunnels and make sure the tunnels are actually being encrypted. That's one way for me to check. Okay, before we get into complex access control lists. Right, because I do know that if I can ping locally from router to router, tunnel to tunnel, it's the most simplest form of the ping that I can have. And if that is encrypted and working with encryption, I can actually start to eliminate a lot of other issues. Right, and that's why I typically would put that into an actual access list for encryption. Okay, that's just a personal point of view. So I say access control list advanced 3000. Okay, that's for advanced access list. And I say, okay, rule. I would never go for rule 0. Let's make it rule 10. Permit IP coming from a source of 10.101.1, right? Going to a destination. The 0, of course, that shouldn't be 2, that should be 0, yeah? The 0 is effectively the whole thing, so it's coming from 10.1.1 specific, 0.0.0.0, going to a destination of 10.1.1.2.0. While I'm doing this at the same time, I'm going to start this as well, so I can start to create the same rules back again. Okay, so access control list, advanced, 3000, right? What do we say? It was rule 10 if I remember correctly. Permit IP coming from a source of 10.1.1.2.0 going to a destination of 10.1.1.1.0. Okay, if I do a display this, oh, that was interesting, this. Okay, I have that over there, and if I do a display this, I have this guy. So coming from 10.1.1.1 going to 10.1.1.2, and going from 10.1.1.2 going to 10.1.1.1, vice versa between the two. Okay, so that's pretty cool at the moment. I also want to say rule 20, permit IP coming from a source of 192.168.1.0, and we say 0.0.0.255 going to a destination of 192.168.2.0, 0.0.0.255. All right. At the same time, I want to do this over here. So rule 20, permit IP coming from a source of 192.168.2.0, 0.0.0.255 going to a destination of 192.168.1.0, 0.0.0.255. Okay. That would be nice if I actually did that destination. Yeah. Okay, and now do I display this. What I should see and display this side is display this is a mirror from the one side to the next here. And we do this, it just makes it a bit easier to read, and that's it. I'm a bit of a stickler for this type of thing. Okay, so what do we have? We're saying rule 10 coming from 10.1.1.2 going to 10.1.1.1, and we've got 192.168.2.0 going to destination 192.168.1.0, and the other side we've got 10.1.1.1 going to 10.1.1.2 and source 192.168.1.0 going to 2.0. Guys, you cannot check this enough times. Make sure this works before you go further. Yeah. Okay, so now I've got access list 3000. And let's start, typically where you'll start with is with the transform set, right? So IPSec transform set, I think let's call it transform set 1, yeah? And ESP, encryption, algorithm, I have a couple of them at the moment, right? So let's use AES CBC 256, okay? At the same time, so I'll also say ESP authentication, yeah? Algorithm is SHA-1. Well, I think that's good. I'll just make some notes here so we can see that we don't mess up anyway. Okay, so let's go into the same side there, and I say IPSec transform set tran1 here, tran1, and we say ESP encryption algorithm is AES256. Brilliant. And we say ESP authentication algorithm is SHA-1. Okay, so we should have all of this done. Display this. You'll see me move quite slowly through this because I always want to make sure that everything is set up properly. Okay, once you have all of this done, you have to create a policy. Yeah, IPSec policy. And let's see, IPSec policy, and what can we call it? Well, let's call it map 1. I think that's what I would call it, yeah, map 1. Then if you check here, they'll say integer, 10, and they'll say IPSec and pure manual. Quite important that you set this up properly. Okay, IPSec and P is automatic negotiation of IC version 1 and 2. So it sets it up so you don't have to create the steps, it will create it for you. Okay, so I definitely want a IPSec and P version. We have to, of course, transform set as, what do we call it, tron 1. Bind that there, and I want to do a security access control list 3000. You'll see that there is an aggregation or per host. Okay, we'll talk about that in some other videos, but for now I'm just going to do standard ACL 3000. Okay, don't do aggregation one side, not the other. IPSec is very finicky, it negotiates, and if things aren't set up properly, they won't negotiate a session at all. Okay, and I've got a remote address. So what am I allowing at the moment? This is quite important, because for my policy, what I'm saying is I want the policy to apply to anybody coming from a remote address of, and in this case it will be a remote address of 10.101.2. Okay, why do I say that? Because what I'm doing is I'm going to start encrypting it on the GRE tunnel. If I encrypted it from the physical interface, it would have been 172.16.2.1. Okay, but since I'm encrypting, I'm going to be applying it to the GRE tunnel. I want it to be 10.1.1.2. Okay, and that's pretty much it, right? All I need now is I need a keychain. So IC keychain, and this is pretty much, from a keying point of view, I'm going to use appreciate keys. So let's call this keychain 1. Yeah. Oh, it just started raining outside. Okay, so that's keychain 1, and then we say appreciate key. And if you look at what type of preset keys you've got, you can either go via hostname or address. Well, for this time I know the address quite well at the moment, so the address is going to be, and if you check, I can actually set up a couple of things here. You're right, I can actually open up completely for all addresses or one very specific address. In this case, I'm going to say it's 10.1.1.2 if I remember correctly. Just wanted to check. Yep. And good. I want to check the whole address, and then you'll see I have to say key and what type of key. For now the key is going to be simple, and what do we say? I think you remember we said test. Yeah, let's just verify. Yeah, that was it. Okay, so all lowercase test. Okay, I can have multiple keychains running here, by the way. Okay, so what have we set up now? Okay, so if you do a display current configuration pipe beginning with Tron, that's a good place to start, and that's my whole setup there. Okay, so what do I still need to set up? I still need to set up all of this information still. So I'm going to keep this exactly the same. Control copy. Right, and all I want to do is remote address. It's going to be slightly different. Remote address is going to be 10.1.1.1. Okay, I'm a bit of a lazy guy. Okay, the keychain won't work. I have to get that right. That is fine. Okay, so keychain. IPSec keychain. Yeah, IPSec. Of course, keychain, and we said that we're going to call it keychain 1. Right, there it is, and we say appreciate key, and we said address, and it was 10.1.1.1, 255, going to, of course, use key simple test. If I remember correctly, yeah, display this, yeah, I'm happy with that. Okay, and we say quit and display current configuration pipe beginning with Tron. Okay, so the access has been bound to it. Everything in theory should be working well. Yeah, I think I'm pretty confident if this should work well. Okay, yeah, it looks pretty good. Okay, so right now nothing's happening, of course, because I haven't applied it to an interface yet. I said I'm going to go to interface tunnel 0. Alright, and then it's IPSec policy, sorry, IP policy. Ah, man, I'm so confused at the moment. IPSec apply policy. I'm just human, please. What do we call it? If I remember correctly, we call it map 1. Yeah, boom. Okay, and I say IPSec apply policy map 1. Okay, and display this. Let's make sure it's in there. And display this, and it's in there. And we say quit and quit out of it. And very quickly display IPSec. Hopefully there's nothing, which there is not. And display IPSec SA brief, and there's nothing at the moment. Okay, so nothing's working at the moment. So let's start. Ping. Right. 10.1.1.1. Okay, this time something's happening. Okay, something happened. Okay, so the first one was lost, the first ping. And this looks quite positive, because I think that there was a negotiation that just happened. Okay, so if I do a display IPSA, I've got IPSec running, and if you do a display IPSec SA, first like this, right, display IPSec SA, there it is. To see a brief very quickly, just a brief view of it, there it is. Okay, and of course on this side I should have a display IPSec SA brief also running at the moment as well. So what I can also do is display access control list all, and I've actually had some matches there on the 10.1.1 network. So if I ping 10.1.1.2, okay, that means it's all encrypted. Just put some traffic through there and display access list to see that it's actually matching up. So if I do ping from here, ping 192.168.2.1, right, you'll see it still works. But if you do a display access control list, there's no line for it to match, which means that that traffic that just happened there is coming from a 10.1.1.1 to 192.168, and that doesn't match in the access list, which means that that traffic that I just did there is not encrypted. Pretty cool. Okay, so how can we check whether it's encrypting or not? Ping -a, I said if it comes from 192.168.1.1 going to 192.168.2.1. Alright, very interesting, that it's renegotiated. Okay, and this is where we talk about that aggregate word. Okay, if you do a display IPSA now, alright, IPSec is still running one IPSec, but this will change. It's a brief. Okay, now I have multiple tunnels. And that's where the aggregate word comes in. If you don't want to have multiples of these for each access control list entry, we use the aggregate command. And there's benefits and of course disadvantages to that as well. But that's not for this video to discuss. Okay, it's just for you to see that this actually works. Okay, there is the brief. Now it's 4 over there. And if I check my access control list, display access control list all, I should have matches there. Okay, Bob's your uncle, man. How difficult can this be? Okay, so what we've pretty much set up is we've set up an encryption tunnel from this point, the green point there. So traffic will enter 192.168, be rerouted because of routing to the GRE tunnel. The GRE tunnel applies the IPSec to it, right? It fires across the WAN with a public IP address, gets to the other side, strips off the public side, forces it to the GRE tunnel. GRE tunnel unencrypts the traffic and fires out the other side. Okay, and that's pretty much it. That's pretty much how I would approach any IPSec setup. I know I haven't spoken much about the IPSec. What I'm trying to show you is the steps I would use. Right, so if something went wrong, the first thing I would do, if I was troubleshooting this network, right, I would check the access lists, whether it's being hit or not. Alright, the next thing you could do in IPSec troubleshooting is to reset. I know that's in a theoretical point of view. You know, if you have 1,500 sites connected with all their tunnels up and running, it's not that simple and straightforward to reset IPSec and IPSec. There will be impact. Okay, but that's one of the things you could use in a small environment. And of course, if you could then, you know, if it's anyhow possible to unapply, is that the right word? Remove the configuration from the interface. Now, this once again is not feasible always. So that's why I really implore you to get things right from the start, right, when you actually set this up. Make sure your connectivity is working before you do anything else. Okay, and then put in some little tests for yourself, like the 10.1.1 into the access list to make sure that's an easy ping to verify. You know, coming from sources to destinations, you don't always have that access to that server or to that PC on the other side. But you should have, in most cases, access to the actual devices, the routers themselves, to do the basic ping to make sure that in principle IPSec is working. Yep. Okay, so I really thank you for your time. I hope it wasn't too long and boring, and I hope you guys actually learned something here today, or at least saw something interesting. Thank you very much. Appreciate it. See you soon in the next video. Bye-bye.